Escaping the front-end monolith. When and how to scale with micro-frontends. Key takeaway. Micro-frontends do for the UI what microservices did for the backend by breaking down the monolith to allow autonomous teams to deploy independently. But this architectural shift comes with trade-offs that engineering leaders must understand before making the leap. Backend teams solved the scaling problem years ago by decomposing massive monoliths into independently deployable microservices. That granted small squads clear ownership, faster iteration cycles, and localized release schedules. Front-end teams, however, were left behind. Even in organizations with sophisticated backends, the front end often remains a single sprawling repository bound to one build pipeline and deployment artifact. Every team that touches the UI is forced to commit to the same codebase and wait in line for the same CI/CD pipeline. At a small scale, this is manageable. But when you scale to 5, 8, or 12 front-end squads, the monolith becomes a severe bottleneck. A broken test in the checkout module can block the dashboard team's critical hotfix. A routine dependency upgrade by one team can break another team's components. Sprint planning can devolve into negotiation over shared resources instead of prioritizing business value. If this sounds familiar, you are caught in the front-end monolith trap. Micro-frontends offer a way out. The concept is simple. Decompose the front end into smaller, independently developed, tested, and deployed pieces. Each piece maps to a business domain and is owned entirely by a single team. A container application called the shell or host handles routing and composes these micro-frontends into a cohesive user experience. There is no single way to build a micro-frontend architecture, and here are 3 dominant approaches. Module federation is popular for React-based ecosystems, where each micro-frontend exposes components the host loads at runtime. The advantage is performance and developer experience, because shared dependencies load once, and updates can be picked up without redeploying the host. The trade-off is high coupling, since teams must agree on major shared dependencies, creating cross-team coordination for upgrades. Single SPA treats each micro-front-end as a fully independent application, allowing different frameworks to coexist. The advantage is ultimate autonomy, where teams make technology decisions in isolation. The trade-off is severe performance costs when multiple frameworks duplicate large dependencies, leading to heavy user downloads. Server-side composition assembles micro-frontends at the edge, or server, to optimize SEO and initial load speed. This approach suits e-commerce platforms, where SEO and fast first render matter most. We caution against adopting micro-frontends just because it is trendy, since they introduce operational complexity. Adopt them only when organizational pain from your monolith exceeds the technical cost of decomposition. Micro-frontends make sense when you have 3 or more independent squads, because coordination becomes difficult below that threshold. They also make sense when teams have differing release cadences, like daily marketing updates, versus bi-weekly core product releases. Post-acquisition integration is easier when the acquired app is embedded as a micro-front-end rather than merged into the monolith. Gradual migrations work well when moving from legacy frameworks to modern ones by rebuilding sections incrementally. For teams of 4 developers or early-stage products, the overhead is rarely justified, and a well-structured Monorepo is usually better. The biggest risk of micro-frontends is visual fragmentation, where the UI feels like multiple products stitched together. The non-negotiable solution is a shared design system owned by a dedicated team and published as a versioned package consumed by every micro-frontend. This guarantees visual consistency while maintaining deployment independence.